Welcome friends, myself Rahul Thakkar from LJ Institutes of Engineering and Technology. In this current video lecture series, we are studying subject of Physics Group-1. Today, we are going to start a new chapter, that is Properties of Matter. In the today's video, we are covering the topics such as introduction, concepts of load and its classification, concepts of stress and strain, and at the end, we will discuss a Hooke's law. You might be aware about the Hooke's law if you have studied it in 11th and 12th science. It is the law which relates stress and strain. Okay? So, let us start with the first topic of today's session, that is the introduction to the chapter. Now, firstly, we must understand what we are dealing with. Okay, so right now we are dealing with the properties of matter, means properties of material. All materials are elastic in nature, and the majority of properties are depending on the elastic nature. So this is a chapter which is mainly used for student of mechanical and civil engineering branch students, because they are the first one to come in contact with the material directly. Okay, so elasticity is a branch of physics which deals with the elastic property of the material. Elasticity is a property by virtue of which body regains original shape and size after removal of the deforming forces. When a deforming force acts on a body, there is a change in its length or shape or volume, then the body is to be straight. So in this chapter, elastic properties of the material and their application for the different users will be discussed. So coming to the first topic, that is the concepts of load. So you might be aware about the load. It is nothing but the application of forces. Okay, so there are various loads such as static load. It is a load which is relatively constant for an extended time, and it is known as a static load. The example of static load is a dead load. For example, if you take this object, consider this surface on which the load is to be applied. If a dead weight is kept on it, for example, let us take 12 hours, 15 hours, 20 hours, with respect to time, the object and the surface are constantly in contact with each other. This load is applying some forces on this surface, and which is constant throughout the entire time range, and such a kind of load is known as a static load. Means it does not vary with respect to time. After a certain time interval, the load applied will be same and will be equal. Okay. Now next comes the dynamic load. The load which varies with respect to the time is known as a dynamic load. Such loads are wind load, the load of an earthquake. They are the examples of dynamic load. You must be aware that wind is never constant. It changes, its load is being varied from certain time interval. After every second, the application of wind load changes. So such a kind of load which keeps on varying are known as a dynamic load. Next comes the normal load. The load which acts perpendicular to the cross-sectional area is known as a normal load. Okay, let us take back the example of the static load. Over here, the load is kept. Now this load will be mg, mass into gravitational acceleration. It is applied directly perpendicular to the surface right now in this condition. So such a kind of load which is perpendicular to the surface are known as a normal load. Okay, consider a load applied in this direction. Consider a load applied in this direction. So this is the surface on which the load is being applied. Let us take the example of pushing load. Okay, so load which is perpendicular to the surface is known as a normal load. Okay, so normal loads are either tensile load or compressive load, and it produces a linear deformation in the object. Now next comes the shear load. It is a load which tends to produce a sliding failure of a body along a plane parallel to the direction of the load, or the forces is known as a shear load. Let us take the example of a water flowing, okay, from higher level to lower level. There is a constantly the shear load applied on the molecules of the water particles. So such a kind of load is known as a shear load. We will discuss it in later, okay. But for example, for an instance, just remember shear load is a load which is applied parallel to the surface area. At this instant, for this object, if the load is for this surface, let us take the example for this surface. Okay, so base is kept steady, and if the load is applied in this direction, you can see the hand movement. So it will create a deformation on the upper surface. Okay, so such a kind of load is known as a shear load. Okay. Now next comes the concentrated load. Concentrated load is the load which is applied at a particular point. Okay, it is also known as a point load. Okay. Now next comes the distributed load. It is a load which is distributed over the entire length or the area is known as a distributed load. It can be of two types: uniformly distributed load and uniformly varying load. If the load applied is throughoutly uniform, okay, so that is UDL, uniformly distributed load. And if the load applied is varying, somewhere over here is 5 Newton, over here is 1 Newton, over here is 10 Newton, okay, such a kind of distribution of load is there. So that is known as a uniformly varying load. Okay. Now let's move further to the topic of concepts of stress and strain. Okay. You might be aware about the stress. What is stress? It is restoring force per unit area. What is stress? Stress is the restoring force per unit area. It is denoted by the symbol sigma. Sigma is equals to F by A. Now you might be confused between the stress and the pressure, because pressure is also force per unit area. Unit is Newton upon meter square or Pascal. Over here for the stress, you can see sigma is equals to F by A, means it also has a unit Newton upon meter square. So what is the basic difference between stress and pressure? You might be know being an engineer, okay? So I will explain to you what is that. Whenever an external forces is applied on a body, let us take the example again. Consider this to be a body, compressible body. I apply a pressure on it. I will apply a load on it. So that force per unit area will be equal to the pressure. But according to the law of inertia, this body will resist the applied forces and will try to regain its original shape. So internally some forces are generated which are trying to restore the original shape of the body, and that restoring force per unit area is known as a stress. Okay, what is pressure? Pressure is the external forces which I have applied on the body per unit area. And what is stress? Stress is the restoring force generated due to the application of external forces. Okay, that restoring force per unit area is termed as a stress. So there are various types of stresses. First one is the longitudinal stress, volumetric stress. Volumetric stress is also known as a bulk stress, and the tangential stress. Tangential stress is also known as a shear stress. Okay, so let us discuss the three types of stresses. First, take the example of longitudinal stresses. Longitudinal stress can be compressive or a tensile. As you can see in the figure, a normal load is applied on a cubical body. You can see the load is normal, force is perpendicular to the cross-sectional area. So over here, if stretching is there, means it is a tensile load is there. Because of that, the tensile stress will generate. Okay, and in the second case, you can see the compression is there, and because of that, the compressive stress will be generated inside the body. Okay, Now next comes the volumetric stress. Volumetric stress is or bulk stress. So volumetric stress is nothing but the pressure, because to change the volume, force must be applied normal to the pressure. You can see in the figure, because of the application of the force or the pressure, the volume changes, the diameter is reduced. Okay, first one you can see the diameter corresponding to the original volume is there. Thereafter you can see the delta V, there is change in volume is shown. Because of the change in volume, the diameter is reduced. Okay, the diameter corresponding to the volume of the object as a result of pressure acting on it. Okay, you can see in the figure, because of the applied pressure there is a change in the volume of the object, and because of that the internal restoring forces is generated inside the body, which tries to regain the original volume, and that stress that is known as a bulk stress or volumetric stress. And thereafter the last one comes the tangential stress, which is also known as a shear stress. So it tries to opposes the shear load, okay, or the shear forces. You can see the example of shear forces. So over here the tau is equals to F by A, where F is the restoring forces. Now let us discuss strain. So what is strain? It is defined as the ratio of change in dimension to the original dimension. Strains are of three types: longitudinal strain, volumetric strain, also known as a bulk strain, and the third one is a tangential or shearing strain. So first, for longitudinal strain, epsilon L, that is nothing but the delta L by L. If you take a body and stretch it, because of the application of force, the length is increased. The change in length is delta L divided by total original length of the object. So that delta L by L is there. As you have seen in the volumetric stress or the bulk stress, there was a change in volume. So that volumetric strain can be given as epsilon V is equals to delta V by V. And thereafter comes the tangential strain. In tangential strain, the volume of the object is same, the dimension of the object is same. Okay, length is same, but the orientation is changed. If you can see, the first one, the square is there. Before application of force, there is a square, but after the application of force, it becomes a parallelogram, as you can see in the figure. So because of that, the orientation or the theta angle is changed. Initially it was a 90-degree angle, but after that the angle is changed. So that is that angle theta is known as a tangential strain, and you can calculate it by the formula angle is equals to arc upon radius. So over here that arc is delta L and the radius is L. So that is how you can calculate the tangential strain. Okay. Now moving further to the next topic, that is the Hooke's law. So it gives a relationship between the stress and strain. For very small stress applied, stress is directly proportional to the strain. Okay. The ratio of stress to the strain is constant, and this is known as the coefficient of elasticity or modulus of elasticity. So now in the next video we will learn stress strain diagram, important properties of materials such as ductility, brittleness and plasticity, and also we will discuss the working stress and factor of safety. That's in it for today guys. Thanks for watching.